Hey, what's up, guys? It's Dapfro Gaming here, aka Wormrida on Steam, and I wanted to bring you guys a quick intermediate tutorial on how to use retro gadgets and how to interface with a lot of the hardware in retro gadgets. So I just built my first major project called Pocket Cookie. It's an idle clicking game, which is pretty fun, and I must say I have loved to see all the projects that people are coming out with on the Steam Workshop. Well, yeah, most of them at least. So without further ado, let's go over what you're going to learn in this tutorial. Right here we have a basic platforming game. We have some left to right movement, we have a jump animation, and we can collect some coins, which plays audio. Pretty cool. And one other thing it does is you'll notice our score increments by one each coin we collect, and then if we want to, we can turn it off, turn it back on, and it actually saves our score. So we have a save game feature and an autosave enabled every second. So I'd like to say this tutorial is meant to be a little bit more intermediate. You should have a basic understanding of how coding works, what variables are, what functions are, and how to declare that stuff in Lua. If you are a complete beginner, I'd highly recommend watching a Lua for Beginners tutorial because that will cover a lot of things that I'll kind of be glossing over here. So if you do have an idea of how to code, you don't have to be an expert, but you do have to have some idea to follow this tutorial. Then what I'm really going to be showing you is how to interface with the inside of Lua and how that works. So let's get started with the new project. All right, here we are. So first we're going to start off with a very, very basic board configuration. Whoops, not that one. I'm just going to use the biggest boards for now because I don't really care about the size of the device or anything. You know, you could add some styling if you want. We just want enough room for a D-pad and some buttons. Now, in that tutorial I showed you, we really only use the D-pad, but the idea is still the same if you want to hook up your own buttons or the other buttons there. So now that we have the board in place, we can go ahead and solder it together. We're just going to be using one big board here. Nothing too fancy. And the first thing we're going to do is we're going to get all the chips on the board. So let's start off with our output. We're going to want a screen, and we're just going to be using the biggest screen here. If you want a bigger screen than the biggest here, this is just 64 by 64. You could theoretically stitch two screens together, and then you would have to write a controller in the code that would essentially determine where to draw your sprites depending on which screen they were on. So we're just going to have a screen for output, and then we're also going to have some input. We're going to get the D-pad and two buttons. Now the buttons here are kind of just for show. I didn't actually program any functionality into the buttons in our little demo game. But like I said, you can just add that later if that's something you're interested in. And then the D-pad. Perfect. So next up, we're going to go over the chips that we'll be needing. So because we have a screen, we're going to need a video chip. All right, and we're going to place these on the back so that way we have more room on the device. Now, we're also going to need a CPU because we want to write code that interacts with everything on the device. We're going to need an audio chip for the coin sound that plays. And let's see what else. We are going to need memory. This is what allows us to save our game. Now, this smallest memory is 4,096 bytes, which is honestly plenty for what we're doing. I mean, if you're just saving a bunch of numbers or some text, the smallest one will work fine. If you need more memory, you can select something bigger. And then we will need a ROM chip, and this is what allows us, this is read-only memory. It allows us to import our assets, and the assets folder will be in the description below. You should go ahead and download that now because the next step is going to be importing those. It will be a zipped folder. You'll just have to unzip it, and I'll show you what to do with those assets. So now that we have the device set up, we can just go ahead and put that back on. We're going to come over here into the gadget, and we're going to go to edit. Now the first thing we're going to do is get our assets. So if we want to import our assets, my assets are already here. I have a few from some different projects already, but if you don't know where to import them, you're going to come over here to folder. Do you want to open the retro gadgets folder? Yes. Now this is opened up on my other screen. So here we go. It's just this folder. You'll drag and drop the 3 assets that I have linked in the description. You'll drag and drop them here under your retro import. All right, so now let's go back to Edit Gadget, Edit. Once they're in the imports folder, you can import them into the project. First, we'll do the coin sound. Next up, we have the coin sprite. We have our, where is it? The dummy sprite. Now, for me, I called it dummy sprite 1 just because I had to make it a little bit smaller. And I think, yeah, it's just these 3. So now anytime you open up sprites in Retro Gadget, you're going to want to go and edit them because you're going to have to edit the default size of the sprite. So you'll see the coin here actually only takes up 1/4 of this window because the coin is an 8x8 sprite. So what we're going to want to do is we're going to want to set the width and height here to be 8x8. And just a note, the maximum size here is going to be 256 by, I believe, 256. So that's the largest sprite you could import. Remember, anything larger than 64 by 64 is not going to show up on this screen because those are the screen dimensions. And so I have the coin to be set to 8x8, and then our dummy sprite is a 16 by 16 asset. And so, yep, we'll see 16 by 16. It looks really blurry, except when it's zoomed out, you can kind of see what's going on. And the reason it's blurry is because I took this from an open source sprite editor online and I compressed it. And so you can find higher quality pixel sprites than this, but this will work just fine for the tutorial. No need to worry about it. All right, next up, we are going to start coding. So this is where I think you should have some knowledge of code. And because I already have this laid out, I'm going to be going over this and coding along with you step by step. We're going to start with the variables, and then we're going to get into the functions later and, you know, some best practices to do. Since this isn't a large project, we're just going to be using one script for the CPU. If this were a larger project, you probably want to have multiple scripts to handle functionality individually. That way, your one script doesn't become so large and cluttered that it becomes hard to manage. So I think I'm going to zoom in on this with my software, with my video editing software, so that way you can see it a little bit better. But our first step is going to be setting up the interface with all those chips on the back. So to do this, we're going to create some local variables. These will only be seen from this script. Remember that for a local variable. And then, yeah, so if you had other scripts that wanted to call things like your video chip and your screen, you could not refer to these as local. So we'll start off with local video. This will be a video chip. And this is going to be equal to GDT. This stands for gadget, right? And this essentially references everything on our device that we have built on the desk to the right. GDT dot, where is it? Should be, oh, did I forget a video chip? No, there it is. Video chip 0. And we can use audio complete for that. So next up, local, we'll call it screen main, just in case we were to have another screen on here. It's going to be of type screen, and it's going to be GDT.screen0. The 0 references the 0 index of the number that of objects of that type that you added to your gadget. So if we had 2 screens, the 2 would be video chip 0 and video chip 1 to refer to them individually. Now I like to set these up so that way we don't have to constantly refer to GDT.videochip0, and it helps too so that way if you have a ton of video chips or a ton of inputs, you can differentiate them with your own custom variable names. So next up we'll do the ROM. It's going to be of type ROM, and that is going to be GDT.ROM. Now local, let's go with our audio. It's going to be an audio chip, and that is going to be GDT.audiochip0. And lastly, we have the memory, which is of type flash memory, which equals GDT.flashmemory0. There we go. And next up, we are going to set up the inputs. We're going to do this 2 lines below just to differentiate. So local, we'll just call it a lower button. I mean, these won't be used in our tutorial, but just in case you want to know how to set these up, I have it here, GDT dot LED button 0, and then local upper button, LED button dot LED button 1. And I like to use camel case for variable names and function names. And last but not least, we'll have our D-pad, and I just call this movement button. We will be using this, so this is important. This will be of type D-pad, which equals gdt.dpad0. So I just want to take a second and say, in case you don't know, you're like, how did you know that this was going to be of type D-pad? Well, partly because I was looking here, but also one thing you should do when you're programming is open up the documentation website. You should essentially have this up on another monitor or just in the background at all times. Whoops, trying to drag this over to this monitor. And essentially, under the Retro Gadgets documentation, if you come in here and click on their API, oh boy, did it bug out? Yeah, there we go. You can come under here and look at modules, input. There's the D-pad. We can see what properties it has. It has an X, a Y, different input sources, and on event change, an event handler for it. So that's kind of cool. The properties here, you can see it's going to be read-only. So we refer to those with a period. And then if we look at something like output, like our screen, actually miscellaneous. Look at the video chip really quick. We can get the width and height. We'll refer to these with a period since it's a property. And then the methods, we'll use a semicolon because it's a function that we can call. And so there's a lot of functions here that you can use, such as draw a sprite, make a triangle, draw the triangle, fill it, fill a rectangle. And this is essentially what you're going to be looking at to create objects on your screen. So it's important. You should know how to read the documentation. Go ahead and give it a look over, and we'll get back into the tutorial here. So now that we have the movement button set up, what we're going to want to do is we have to set up and say that our screen's video chip is actually the video chip that we specified earlier. So screen main dot video chip, that's a property that we're setting, equals video. And then also for the audio here, I happen to know that the audio it just plays really, really loudly at default. So we're going to go audio, the function called set channel volume. And what we're going to do is set the audio volume to 30% and on channel 1. Since we're only playing one audio clip, we're just going to be using channel 1. But you can set the volume individually for all audio channels if you wish to. So next up, we're going to define our assets, right? And we just imported those, so we should now be able to refer to them. The only asset that we didn't import that we're going to be referring to is the font, and this is actually a built-in font that is used. According to the docs, it's the only font that's supported. I'm not sure if that's true. I haven't tried importing my own custom fonts or anything, so we're just going to be using the built-in font. We're just going to call it font. It's of type Sprite Sheet. And we're going to refer to our read-only memory, rom.system, because it's built in, and then Sprite Sheets. And the name of the font is what we refer to in the brackets, and it's just called standard font. Next up, we are going to refer to our dummy Sprite Sheet. We're just going to call him dummy because he's a crash test dummy. It's going to be a Sprite Sheet, and it's going to be rom. This time we're going to use user because this is a user imported asset, or Sprite Sheet, I should say, to differentiate. And then we called it dummy sprite1.png. Next up, we have the coin, local coin. It's going to be a Sprite Sheet equals rom.user.spritesheets. And it is just called coinsprite.png. And last but not least, we have our audio sound. I just call it coin sound. This is going to be of type audio sample. And that's going to be rom.user. Got to capitalize user.audio samples. And the name of the sample is just coinsound.wave. Real straightforward. Next up, we're going to go over our player controller variables. So, whoops, controller vars. And what we're going to do is we're going to have two variables for the position. That's going to be the X and Y position because the screen is an XY grid. Player, we'll call it player X position. It's going to be a number, and we'll just initialize that to 0. So the X equals 0 is going to be over here on this side of the screen, this left side. Y equals 0 is going to be the top of the screen. So the origin is 0, 0 is the top left of the screen. So with that in mind, local player Y position, it'll be a number, and we'll set that equal to 48. Now, why 48? So our player is 16 pixels tall, and our screen is 64 pixels tall. So since it draws from the top left of the player, we want to draw our player from Y equals 48, and it will draw him starting there from his head, and then his toes will be at Y equals 64, aka the edge of the screen. And then we have local. We'll have some Boolean values, true, false values for whether or not he's jumping. We'll initialize these to false because right off the bat he won't be jumping or falling. Set those both equal to false, and then we are going to have our local player profile. This is going to be used to save our game essentially. And so the player profile is a type table. And we'll get more into this later. We can just initialize it to blank because we'll deal with initializing a save once we get to that part. And then there's just one other variable here, and we're going to do local player facing idle equals 2. And what this is this is a number to control our idle animations. So I think this would be a good time. We can just talk about how the animation system works. If we go and look at our sprite here, whoops, our dummy sprite, idle animation equals 2. So these are 0 index, which means the first item here on the left on the x-axis is 0. And then if we go over, that's 1. And then this is 2, right? And then if we count from the y, 0, 1, 2. So the way it works for the idle animation is we want to know if he's facing right, we're going to use the Y position 2. If he's facing left, we're going to want to use the Y position of 3. And this is how we're going to be differentiating which animations to use depending on which way they're facing. So you'll notice actually the top row here, they're all facing to the right, and the bottom row, it's the exact same textures, just reversed. And I know, some of these textures, they're not the best. I try to clean them up a little bit. It looks like I was unsuccessful in a few areas, but it's all right. It'll get the job done for what we want to do. So next up, we are going to have our coin variables, right? So as you can imagine, we're probably going to want to keep track of things like the coin position. Is the coin spawned? And then we're going to want to use a counter variable that indicates, how long has it been since the last coin was collected. So local is coin spawned. Boolean, we'll set it to false initially. And then next up, we'll do our coin position. We'll say it's a number, and we'll just set it to equal to 0. When the coin spawns, we'll change this. It's a good practice to initialize your variables to some value. That way you don't come across a null value error if you try to compare a variable before it's assigned. So what that means is if we didn't set this to 0 and we just said, okay, this is a number, it'll let us do that. But if we try to say, okay, is coin position greater than 5, we're going to get an error because coin position hasn't been set yet. So local, what's next? Coin spawner. And this is going to be a number equal to 0. We're going to use that as a counting variable for our time-based animation system. Next up, we have another time variable, local tick counter. It's a number equal to 0. And the last counter is going to be called global tick count, which equals 0. And so just to differentiate, this tick counter is actually going to be used for the player and the player animations. This global tick count is just going to tell us how much time has passed since we started the program. Okay, so now let's get into setting up our update function. Now I'm going to code these and then comment them out because we haven't created any of these functions yet. But essentially, it's going to work. Our update function is going to work like this. So first, we're going to do video clear and color.black. And just to clarify, this update function is called once per tick. You'll notice that the program runs at about 60 ticks per second. You know, you could think of that as 60 frames per second. So anything you put in here is going to be running every tick, or every 60 times per second. So we're going to start off with clearing it, and what that allows us to do is it allows us to draw new animations every tick, and then clear the old ones. So it gives us the appearance of movement essentially. And then the first function, I'm going to comment it out. We're going to do player controller. This is going to manage our player and if they're moving or not. Let's scroll down a bit here. Player controller, spawn coin. It will manage our coin spawning. Then we're going to have player collision. This will check if our player has collided with the coin and if it should be awarded, a score. We'll have draw score, which keeps track of our score in the top of the screen. It just draws that. Pretty easy function. And then lastly, we will have increment ticks. And that's going to keep track of our tick counters here, which will be used for the player animation, the coin spawning, and it'll even be used to seed some random number generation, which we will get to in a little bit. And then last but not least, I'm just going to fill this out now to set up for our save game. So we'll say if global tick count mod 60 is equal to 0 and global tick count is greater than or equal to 60, then what we're going to want to do is save game, right? And we haven't made that function quite yet. That's probably going to be the last thing that we do, just because anytime you create a save game function, you have to know everything that you're going to save. And so it's usually better to do that at the end of your program, I think, rather than at the beginning. Otherwise, you'll constantly be updating it with new variables that you want to save. And so just to explain what this means right here, if you haven't seen the percent sign in coding before, usually it stands for modulo or modulus. And what it's saying is if the global tick count divided by 60 has a remainder of 0, which means if the global tick count is a multiple of 60 and the global tick count is greater than or equal to 60, then we want to save the game. The reason we have this second part right here is because any global tick count that is below 60, 59 divided by 60, it's going to be a really small number, and the program might just say it's 0, but we actually don't want to save at that point. So this extra condition prevents us from saving multiple times within the first 60 ticks of the game starting. And so basically what this is doing is it's saying every 60 ticks, when the global tick count is divisible by 60, we want to save. And this is going to be our autosave feature. You could turn this up if you wanted. You could say, 120 if every 2 seconds, or 120 ticks, then we want to save the game. But it's up to you. So let's start off with increment ticks. This is going to be our easiest function to do, just because it's pretty straightforward. Whoops, we've got to get out of the update here. Let's get ourselves a bit of room. Function, increment ticks. We'll draw the end there, and all it's going to do is increment all of the ticks that we have specified. So our tick counter is going to equal tick counter plus 1. Our coin spawner is going to be equal to our coin spawner plus 1. I really wish there was a better way to write this specific line out in Lua, but unfortunately they do make you write the variable twice, and then global tick count is going to be equal to global tick count plus 1. And so this is going to be keeping track of our time. Our time, like I said again, our global time, the time since the last coin was spawned, and then our time for player animations, which is tick counter. You know, ideally that should probably be named something else, but when I first made this, that's what I went with. So let's see, next up, let's start coding the player controller. So I just made a basic player, whoops, not player collision. I just made a basic player controller for you guys. I wouldn't say it's anything special. It gets the job done for this tutorial. However, I wouldn't use this player controller if I were going to make a full platforming game. You know, people that specialize in 2D platformers probably have much better controllers than what I'm writing here, but it works, and it's just to teach you the basics, so I think it accomplishes its task. So for our player controller, if we think about it for a second, our player, what it's going to do is, we should comment, manages player movement. So our players are going to be able to walk left and right and jump up and down, and that's essentially it. So let's first check if they are walking to the right. So if player move, or actually we should probably handle if they're idle first, just because we want to make sure that we're always drawing the idle animation before the other animations. So let's say idle, we'll leave a comment. It's great idea in practice to comment your code, so if you come back to it, you know what's going on. So for the idle, we're going to check if our movement button .x is equal to 0, which means they're not pressing left or right here on the D-pad, and the movement button .y is equal to 0. Then what we're going to do is set the tick counter to 0. Oh, it looks like I forgot the then at the end there. Tick counter equals 0, and we are going to call our idle function, which we don't have set up yet. Right, so we'll just comment that out, and then we'll say end. That's the end of that statement. So next up, the way I have set up this movement controller is that we are essentially going to be playing an idle or a walking animation or running animation once every quarter of a second. And so to play it every quarter of a second, that would be 15 ticks, right? Because 60 divided by 4, that's going to be 15. And so every 15 ticks, we're going to want to change the run animation if we're running. And if our tick counter gets beyond 29, or if it gets to about 30, that's half a second, we're going to want to reset it. So that way we can set a boundary on when we want to play our running animations. So the next thing we're going to do is set up that boundary for the tick counter. So if the tick counter is greater than 29, that is our player, remember this is our player animation counter, then we're going to set it back to 0. Because in total, an entire round animation should only be 30 ticks, and if tick counter starts at 0 and counts to 29, that is 30 total. Okay, now we can finally work with some of the movement. So we'll check, we'll start with moving right. So if movement button .x is greater than 0, then that means they're pushing right on the D-pad. We'll tab over. We'll say player X position, that variable we created at the top, is equal to player X position plus 1. So we're just going to be moving him by 1 pixel to the right. And then we are going to call a new function that we have not created yet called walk. All right, and then next up, we're going to use an else if statement because we don't want him to move left and right at the same time. If player movement button.x is less than 0, then we're going to say player X position is equal to player X position minus 1. And we are going to call the same walk function. And so the way we differentiate between these two is we're going to be calling the first walk with a parameter of 2 and the second walk with a parameter of 3. And if you remember what I showed you with the sprites earlier, this is referring to the y equals 2 row on the sprite sheet, and this is referring to the y equals 3 row. So the walk function will just, it'll say, okay, which row of the sprite sheet are we looking at? And then we'll play those animations. And then that'll be the end of this if statement. And so next up, we want to check if the player's jumping. So we only want them to be able to jump if their player is on the ground. And for us, the ground would be the player position equals 48, right? Because that's when its feet are at y equals 64. So if someone presses up on the D-pad, right, our movement button.y, if it's greater than 0, they press up on the D-pad and their player position, and player y position is equal to 48, aka they're on the ground, then what we're going to do is set jumping equal to true. And then the last bit here is a little bit of logic for jumping and falling. We don't want them to be jumping and falling at the same time. Essentially, jumping is the up animation, falling will be the down animation. So we'll say if jumping is equal to true, then we'll say jump animation, right? We haven't created this yet, so we'll comment it out. And then we'll say else if falling is equal to true, then we are going to play our falling animation. So this is the basic player controller right here and how it's going to operate. So just to recap, we have idle, we have our reset tick counter for animations. We have our manage left and right movement, manage jump action, and then right here is essentially differentiate between jump and fall. So that's our basic player controller, right? It's just moving around and jumping. You could make it more complex if you're doing something bigger. So next up, let's start with the jumping and falling animations. Actually, no, let's go ahead and get our walk animation in so we can check out what that looks like. So we'll be creating a new function down here, function walk, and just like we passed the 2 and 3, if you saw that walk 2, walk 3, it's going to be expecting a parameter here. And this parameter is going to be, we'll call it direction, and it is a number. And it's just going to differentiate, like I said, which row in the sprite sheet that we're going to be using for our walk animation. So we'll have local animation num. It's going to be a number, and we'll just set it equal to 2. And then what that is for is that shows which walk animation we're going to be starting on, but we'll be updating that here in just a second. So basically, how we know which animation or which sprite to use is going to be depending on the value of our tick counter, which manages our player animation. So we'll say if tick counter is greater than or equal to 0 and tick counter is less than 15. So if it's in the first quarter of a second that our player has started walking, then we'll say animation number equals 2, which is the first animation in our animation walk series. There's only 2 animations here, so it's pretty straightforward. If you want to set it up with 3 animations, you would get a more detailed sprite walking, right, with 3 different frames. But the 2 frame gets the job done. So then else if tick counter is greater than or equal to 15 and tick counter is less than 30, then we will say animation number equals 3, right? And we can go ahead and end that. All right, so the next thing we're going to want to do for the walk animation is, so we've specified here which animation we want to use. This would be considered the column on the sprite sheet, and then the direction is going to be the row. So this allows us to specify exactly which sprite to display on the screen at exactly which time. So that's why this is a time-based animation system, because our animations are going to be based on a time period rather than where the player is in 3D or 2D space in this case. So next thing we're going to want to do is draw the sprite. So we'll call our video chip right here. We called it video, and then we'll be using the function draw sprite, right? And now draw sprite requires a few different variables here, or parameters I should say. The first one is the position of the sprite on the screen. So this is going to be a vector2, and a vector is just, you can think of it as like a two-dimensional array for numbers. Okay, so it's an X and a Y, right? If we're playing Battleship, it's an X and a Y. And so we already have our player position, player X position variable, and our player Y position variable. So we'll want to draw it there. The next parameter that it accepts is which sprite sheet we're going to be using, which is dummy. Oops. And then we have to specify the animation X on the sprite sheet, which is our animation number, and the animation Y, which is going to be our direction. Next up, to color the sprite, the default is color.white. This is the tint is what it's called in the documentation. I think if you had a white sprite and you wanted to put a tint on it, you could theoretically, get a white and a red sprite and a blue sprite all out of just the same sprite sheet. You wouldn't have to create separate sheets. Just by coloring it white, this is the default, so we're just going to go with the default colors. And then we'll say, for the background for the sprite, we'll say color equals black, color.black. You may want to change this to color.clear if you notice your sprite has a black box around them and it's drawing over other things in the scene. However, for this, we're keeping the black background, so keeping the color as black is just fine. You'll see that we change this for the coin to clear, so that way the coin doesn't draw a black border over our player. Okay, so now that we have that set up, we should be able to uncomment the walk function up here, and we should have basic player walking if we have done this correctly. So if we, there we go. We don't have the idle animation yet, but left and right, we just have a basic walk sequence, and none of the other buttons do anything yet. Perfect. Next thing we'll do is let's do the player idle animation. Get that set in so that way our guy is just sitting there and doesn't disappear if we're not pressing a button. So for the player idle function, we're just going to call it idle. And basically we're just going to draw the sprite depending on which way they're facing. So let's go ahead and copy this draw sprite code. And it's always best to tab over the parameters. Actually, we can put that at the back there. Tab over the parameters so that way you know it's not part of the line above. All right, and so for the idle animation, the X value here is a constant because our player idle happens to be in the second position on the sprite sheet, or the second column. And if we start counting at 0, that would be 0, 1, that's the second column. And then our direction is just going to be called our player facing idle. That is the variable we already defined at the top, right? And so we already said, I think we specified it. Oh yes, we did skip it on accident. Okay, in the player controller, so after the player walks to the right, we want to specify the player facing idle variable. is equal to 2, which refers to the row on the sprite sheet, the second row, and then otherwise if they're facing the left, if they move to the left, we want the idle animation to be the one where the sprite is facing left, which is the third row. So that should update that variable. So now if we stop pressing anything, our sprite should just be here. Is he? No, he is not. We forgot to uncomment our idle function call right here. There we go. So now he's just sitting here. See, now we have an idle animation. Pretty cool, huh? And jump doesn't do anything yet because we don't have that coded in. So next up, we are going to go with the jumping animation. So let's go function, jumping animation. And we are going to use the same local animation counter, just like we did in the walk animation. And just in case you don't know, when you specify a local variable on the function level, it cannot be seen by other functions. So this animation number is separate from this one, and these cannot be seen outside of the function that they're called in. So we set our local animation number, and then we are going to create some jumping logic, right? So it's a little bit counterintuitive, but essentially if the player is decreasing in Y position, that means they're going up on the screen. And if they're increasing in Y position, that means they're going down on the screen or falling. So we'll say if player Y position is greater than 32, this is essentially going to be a check. So that way, if they've reached a certain point in their jump animation, then we want to switch it to the second jump sprite. Then we'll say animation number is equal to 4. And player Y position equals player Y position minus 1, right? That's moving up on the screen. And then we will say else if player Y position is greater than 24, then we'll say the animation number is equal to 5. And the player Y position is equal to player Y position minus 1. And I'll explain this a little better in just a second. And then lastly, else if the player Y position is less than or equal to 24, this is going to be our stop condition. So essentially, if the position of the player is less than or equal to 24, then we want to stop jumping. We are at the maximum height that we want to get to. Oops, 24. Then we'll say jumping equals false, and falling now equals true. And end. Oh, there we go. Else if player Y position is less than or equal to 24. Okay, so just to clarify, this, wrong comment type, manages the second animation in our jump series. This right here is going to manage the first animation in jump series. And this right here is going to specify at which height we stop jumping. And I know it's a little bit counterintuitive using a less than when you're thinking about jumping, right? But essentially, when the player jumps up, the Y position decreases, so we have to check if it's less than a certain value to specify the maximum jump height. All right. Lastly, for the jump animation, we're just going to want to draw the player. So we'll go ahead and copy this idle animation. And we will paste this in. Go ahead, just going to say go ahead and tab some of these variable or parameters over. So, oh yes, the vector should also be tabbed. So we will want to draw the sprite at their X position and their Y position, which has been newly updated in our jump animation. It'll be the dummy sprite. We're going to use our animation number here, that local variable that we set, depending on the height. And then we are going to continue using the player facing idle because that specifies which direction they were last facing. And we keep the last two parts the exact same. So pretty straightforward. We should now have a basic jump animation, although the player won't fall, I don't believe. No, we didn't uncomment it from our player controller. Where is it? Here we go. Jumping animation. Now this probably has some goofy, did I spell it right? Animation. No, it's just jump animation. So this might have some goofy functionality. Yep, if we take a look, we don't have a falling animation yet, so our player goes up to the jump height and he stays there. But you can see that he does play two separate animations before getting to the jump height. So the next up is the falling animation. It's going to be very, very similar to the jumping, except we're going to do things in a slightly different order. So let's start with function falling animation. We'll say local animation num equals 4. And then we will do the same thing. We'll have some checks depending on which height they're at. So the first height is going to be ground level. So as they're falling, our first catch should be, have they reached the ground? If they've reached the ground, then we want them to stop falling. So basically, if the player Y position is greater than or equal to 48, right? Because 48 is ground level. Anything above that is below the ground. Then we'll say falling equals false. And just to make sure jumping is also false, although it should be set to false already if we're calling the falling animation. And then we'll have else if. Now I'd like to have an empty line there just for readability. Else if player Y position is greater than 32, then our animation number is going to be equal to 4, and our player Y position, player Y position equals the player Y position plus 1, as in they're going to continue falling. And then else if the player Y position is greater than or equal to 24, which essentially means these two catches here, it might seem a little odd that we're going to check if it's greater than 32 and greater than 24, but this greater than or equal to 24 is going to be the top of our jump animation. So essentially there's going to be a small, about, what is that, 8 pixel gap there where we want to play one animation and then we want to switch over to the other falling animation before we hit the ground. And so before we hit the ground is at less than or greater than 32, and the top height is going to be at greater than or equal to 24. Then we will say animation number is equal to 5, and player Y position is equal to player Y position plus 1, right? So we want them to keep falling, and then we will say end. And then lastly here, we are just going to draw the sprite again. So we can go ahead and copy that, Control C, come down, Control V it. Now that should be there, and these can be tabbed over 1. So let's see here. We are going to continue to use the animation number, this local variable, and then the player facing idle will also be specified. And then just a little refresher. So this animation number is switching between 4 and 5 depending on where he is in his jump height. So if we look at our dummy, 0, 1, 2, 3, 4, 5, right? So this is kind of our, I view number 5 as the top, like when we're at the peak of the jump, his legs are kind of backwards, his arms are outstretched. And then 4, his legs are stretched out and his arms are in front of him. It's like he just jumped. He's at the top of his jump height there. And then, so we're essentially just specifying which one of these we want to use at which height right there. And then, of course, player facing idle is going to specify is it the top row or the bottom row. Is he facing right or left? So we can come back in here and let's see, what else do we have to do? Well, I think we might be able to start working on the coin, but let's go ahead and give this a test first and see if we coded in our jumping and falling correctly. So we come in, we can walk left and right. Every quarter of a second, it changes the walk animation. And then when we jump up, see, his legs are outstretched and then they kind of go back behind him when he's at the top, and then it switches and does the animation in reverse on the way down. So you can kind of do a jump up, move to the left, and it handles that animation. Pretty cool. So next up, let's handle the coin spawning and how that all works. So we do use a little bit of randomness in the coin spawning, so that way we get a random spawn each time, and I'll show you how to use that. So let's see here. If we look back at our draw function, what we have left to do is spawn coin, or our update function, spawn coin, player collision, draw score, and save game. Let's start with spawn coin here. Oh, we gotta stop the app. So spawn coin. We'll just, actually we'll start creating these just underneath here, so that way we can still see what we have to do left. Function spawn coin, whoops. And then so we're gonna check that Boolean variable that we made at the top is coin spawned. If is coin spawned equals false, so the coin has not spawned yet, and our coin spawner time is greater than 180. That'll be 180 ticks or 3 seconds, right? Roughly 3 seconds depending on the hardware that's being used. Then we want to do math.randomSeed. Now, if you haven't worked with random numbers in a program before, such as like Python, I think the best way I can describe this is similar to Minecraft, right? Minecraft's terrain generation is random, but you use a seed each time to get the same terrain generation depending on the seed. So essentially, if we use a different seed each time, then our random number that we generate will be different. But if we use the same seed each time, then the random number that we generate will be the same every time. So kind of interesting how that works. So what we're going to use for our random number here, because we want the coin to spawn in a different position every time, is our global tick count, right? That global tick count is incrementing by 1 every tick. So it'll be a different number, every second of the program runtime. And then we'll go coin position equals math.random, and we will say 56, right? So this is going to generate a random number between 1 and 56. The reason we chose 56 here is because the coin itself is actually 8 pixels, and if we're drawing from the left-hand side of the coin and we want the entire coin to be on the screen, then essentially we will have to have an 8-pixel gap there between the numbers it can generate and where the coin and the edge of the screen. So 56, because if it were at 64, then the coin could potentially spawn out of bounds. And then we'll say is coin spawned is equal to true. We're going to have an else if, so that handles the if the coin is not spawned yet. If coin not spawned yet. Otherwise, here we're going to say if the coin has spawned, then we're going to want to show it, right? So else if is coin spawned is equal to true, then we're just going to draw the coin. So video, draw sprite, and what we're going to do is a vector2 position. Remember, we updated that coin position there with a random number, so that's the x value. So we're going to say coin position, and then the y value, we're going to set this manually to 26, just so that way it's right above the player. Okay, you could theoretically also create the y value as a random number, but then, you know, our player can't jump the full height of the screen, so they potentially couldn't get the coin if it were higher. So then we'll do coin 0, 7. That's referring to the first column on the sprite sheet and the 7th row at the very bottom. Color dot white and color dot clear. So the background color that we're setting here is going to be clear, so that way there's not a black box around the coin. Okay, expected then when parsing. Yep. And there we go. So that should be our spawn coin function. We commented that out. Next up, let's go with the player collision. All right, so we'll uncomment player collision, and we'll do this right here under the update function. So function player collision. And essentially what we're going to do is we're going to be checking. Actually, first we should probably check if our coin is spawning correctly, huh? Of course, that's going to error out. There we go. Now we have the coin. Okay, so that works. Good thing we tested that. Now we can move on to player collision. And so we're going to be checking essentially if our player over here on the right, if the coin's position is between his left side and his right side, and if the top of his head is further up than the bottom of the coin, then we can say, okay, essentially he's collided with the coin, and we can despawn the coin, increase the score, and play the coin sound. So we'll say if is coin spawned is equal to true, because remember, the coin position still exists even if the coin is not there. We want to make sure the coin actually physically exists in the world. Next, we're going to calculate the collision box. So if coin position plus 4, and remember this is the coin's x position, and plus 4 would be the middle of the coin, because we're drawing from the left side of the coin, is greater than or equal to our player x position, and the coin position plus 4 is less than or equal to our player x position plus 16, right? So it's essentially if the middle of the coin is to the right of our player and to the right of the left side of our player, and the middle of the coin is to the left of the right side of our player, then we know that that our player is in line with the coin, and now we can just check to see if our player has jumped or not. So if player y position is less than or equal to 30, we know our coin spawns at coin position 26, right? So if the player gets up to 30, that means he's above the coin here. Then we are going to update our player profile first, right? So we'll say this is picked up coin condition, and player profile, we're going to be creating a variable here called score that exists on the player profile table. So the way a table works is essentially you can access and write to different values in the table based on either a number or a string, aka a word. So basically, in player profile, there's going to be an entry called score, and score is going to hold a number equals player profile of score plus 1. So essentially, this is just going to increment the score on the player profile object. So this could be anything. You know, if we wanted to store the player position on the profile, then we could create a new key called position. The key would be the string, and then we could say it is equal to 5, or it is equal to 10, or it is equal to wherever our player X position was, right? Although we're not going to be saving player position with this version of the game. So we're also going to say is coin spawned equals false, because we want to delete the coin when we pick it up. We're going to reset our coin spawn timer, set that equal to 0, and then we are going to play some audio. So let's refer to our audio chip, and then there's a function called play. And what we're going to do is we're going to play our variable, aka our audio sample, called coin sound, and we're just going to play it on the first channel because there's really no reason for us to play it on any other channel since there's only one sound here. And then we can come in here and type all the ends of our if statements. We got to make sure those line up. It might even be better to make the end statement as we make the if, just so that way we don't accidentally get confused there. So let's go above. We already have player collision uncommented, and let's check it out. So now if we go and pick up a coin, we should be able to jump up. Ooh. Yep. Okay, so here's an issue, right? We did not initialize our player profile score. I was talking about this at the very beginning. If we don't initialize our global variables, then you could run into an issue. Attempted to perform arithmetic add on nil and a number. So we tried to add 1 to nothing, or nil, which you just can't do. We got to add 1 to another number that already exists. So the way we're going to handle that is with our saving function, right? So we are going to initialize that stuff when we save the game. Now, for saving functions, these usually, at least when I write them, they take place as the very first thing that goes on in the script, because we want to initialize our save before the game actually starts running. So it actually initializes our player profile before the game starts running. So function save game, it's going to be really straightforward. All we're going to do is say memory, which refers to our memory chip. It has a save function, and we are going to say, let's just save the player profile, which is our global player profile object right there. Now, the first time we save the game, we can save that, but we still don't have anything there. So we actually want to check when they turn on the game, does a save already exist? So we'll create another function called init save, as in initialize save. And basically what we're going to do is check if a player save already exists. So we're going to create a local variable. We'll call it load data. It equals to our memory chip load, right? We're only saving and loading one thing to the memory chip, and that is a table, as in the player profile data type. So local, we have our local data from there. Now we're going to check if local data of score. Now we have to check specifically if an object that we're expecting in our local data exists. So if the score is equals to nil, basically what this says is, load data, not local. So basically, if we try to get this table from memory and the score object does not exist, as in we have not saved before, it can't find anything called score, then we're going to say player profile of score equals 0. That's going to be initializing that variable, and then we will call save game. Otherwise, if it does exist, then we are going to say our player profile is equal to our load data. Okay? So if you wanted to add more variables to your save data, this would be the place to do it right here. Right? So if score, you only have to check if one of them doesn't exist, essentially. But you know, if the others don't exist, this is where you would initialize the variables. So you know, we'd say player X position, or what is it? Player profile of, you know, X position is equal to player X position, or because we know player X position is at least set to a number, right? So if we wanted to save the X position, we could also do it that way. But we're just going to be saving the score for this. So just keep in mind, anything that has to be saved, it has to be initialized here. When we attempt to load data and we can't find a save, then this is where we create the default save. And our default will be the score is equal to 0. So the first thing we want to do before update is ever even called is initialize save, right? Calling this outside of the update function means after we've initialized all these variables, it's going to come in here and it's going to initialize our save and create that first thing first. So it initializes our save variables that we need. Okay, there's just one last thing to do, and that is draw a score. But first, we're going to test if we can pick up the coin. Oh, it looks like there's a compiler error. I am guessing it is probably with that function we just made. Yes, it is. I forgot the end block. So if we start up the game, we can move left and right. We can jump. There's the coin. We want to go collect it. We now hear the coin say select, and we hear the coin sound, and the coin respawns in a random position somewhere between 0 and 64, or 56 technically, because it's drawing from the left hand of the coin. All right, perfect. The only last thing to do is to draw the score at the top. So we are going to do this again under our update function. Function, draw score. And this is real simple. All we are going to do is, and this is pretty straightforward. All we're going to do is access the video chip, draw text. It's going to be a vector 2, right, for the X and Y position. We're just going to say 2 and 2. So it's not the very top left-hand side of the screen. It's got a little bit of a border from the edge of the screen. And this should be vec2. Now we're going to specify the font, and this is that built-in font that we loaded in at the very beginning. And then we are going to say score, and this is, we're going to use something called string concatenation, which means if you have two strings, you can add them together or concatenate them. And so we do that in Lua with the double dot, and then we're going to say toString, because this will convert our number value to a string, player profile, and the value we want to get in player profile is the score. So we're going to add those together, and then the color of our text is going to be white, and the background we're just going to say color.clear, just in case we have something we want to draw over it, such as the player. Let's see here, did I forget a comma? Dot toString. Oh no, I forgot the ending parentheses on toString. So remember that this right here is actually referring to a number. We have to convert that to a string if we want to concatenate it and use string concatenation with our score. So this is going to be score space number. Let's go ahead and give it a shot. Oh, we forgot to call the function. Yep, that seems to be a recurring theme. We can go ahead and comment that out. Our score is equal to 5, so it looks like it already saved some. There we go, score is equal to 6, and we have a basic platformer done here, right? Nothing too complex. You know, with this player collision system, you could theoretically add things like little jump pads, right, for the player to jump on. And you can use the same type of detection system to figure out, you know, if they land on top of a jump pad, right? And that is basically it for this tutorial. I'm not going to go over coloring the device at all because that's covered in the first dev tutorial. I think you guys probably know how to do that. I hope this tutorial was helpful for you. And if it was, please leave a like either here or on the Steam Workshop, depending on what you see this on. I'll probably make a guide for the game just to get the information out there a little better. But other than that, that is all that I have today. If you're interested in seeing some more videos like this from Retro Gadgets, please feel free to subscribe and leave a comment. Let me know, you know. If enough people leave comments saying that this is what they want to see, then I will certainly make more videos. And if you're having issues with your program, you can also leave them below, and I will try to get to those as I see them. So that is it for me. Have a great day, and see ya.